What's up, Algebra 3? It's Coach Jay in the house. Hope you're having a fantastic day on this Friday. Missed the heck out of y'all. Wish I was here with y'all, but as you can see, I'm not. So I'm sorry about that, but I am here to teach you just like I was here. I'll be just as crazy, do just as weird things, and everything will be okay. All right? Sound good? All right, very good. Hey, right behind your screen, right there, I'm actually pointing to it right now, there should be a schedule. Make sure you follow that schedule, and make sure you get the 3 problems that are done. Actually, there's only 2 because I care about y'all. That is due today before 3:30. And then you can also get started on the MML that will be due on Monday at midnight. We will also go through some of those examples and questions as well. All right, we are starting here, and then we're going to go into the actual podcast part. But let's take a look at something real quick. I wanted to discuss something, so I'm actually going to move over here. Yeah, that's a little bit better. Okay, because I want to stand on desks because I can. Okay, y'all good? Okay, so what we've got here is we've got 3 types of transformations, right? And we've talked about graphing on T-charts, but it's a little different here, okay? We have now 3 types of transformations, we call them. Now, when you think of transformations, think of transformers, right? What was originally something like, if you think of Bumblebee, Transformers, what was originally a car could transform or change or metamorphosize into a robot of some kind, or something different, right? And that's exactly what we're doing. We're taking our parent functions, the 6 or 5 that we had memorized, we'll look at in a second, and we're transforming them. So let me give you the basis or foundation of that, okay? So I'm going to give you an example. For instance, if you see here on the bottom, any number that's outside of my parent function, for instance, this is the absolute value of x, which again would look like a v, right? If you have something that is on the outside, that +2, this is we'll do what we call vertical shift. It's going to go up, or if it was minus, we were going to go down. So if you think of absolute value of x +2, what was originally at the origin would then go up to 2, all right? So it would literally transform up and down. Same thing with all the other points. So as you graph it, you will then literally just go up 2. Now let's look and see what happens if we go like x +1. If you look at one like that, instead of, since it's on the inside of that absolute value, we do the opposite. So we say, what makes that equal to 0? And in this case, it would be -1, right? But you think, oh yeah, it's going to move to up and down. Well, because it's on the inside, that moves left and right. We call that a horizontal shift. And because it's x +1, we literally move it to the left 1. Now I'm going to move it to your left. I'm hoping that's your left right there. It could be, I think that might be your left, right? So I'm just going to move it over here. So it's literally going to the left 1 right here. So x +1 will go left 1. +2, what you see is what you get. So that will be a vertical transformation there, up 2. This will go left 1. The negative on the outside will actually reflect. So again, what was originally up, if it's a negative on the outside, we reflect over the x-axis, okay? Meaning what was up now gets transformed to what is down. So what is up goes to what is down, okay? That's when the negative's on the outside. Now when the negative's on the inside, let's say we're right here at 0, 0. What if we reflect over the y-axis? What that's going to do is literally going to rotate from right to left. So what was to the right will go on the left, and what was the left would go to the right. And so that's when the negative is on the inside. I always remember it this way. If the negative is with x inside, then it'll reflect over its opposite, which is the y-axis. If the negative's on the outside like this, it's going to reflect over the x-axis. All right? So hopefully that you see that there. Those are the main parts that we're going to talk about. Again, what is up must come down, right? And because I'm that crazy, what we're looking at is something that looks like this. So if I was up, then all of a sudden I'm reflected. So now I'm going down like this. All right? The things I do for y'all. You have no idea how much I care about y'all. All right. So I think I just pulled something. All right. Good night. All right, I'm seeing like stars now. All right, let's go to this next one, okay? And we're going to get this because now we got to get all squared away. Woo! That was tough. All right, so hopefully you see this here. Now let's look at the basic transformations first. First thing is this. Let's talk about the parent functions, okay? because we remember them. I think we reviewed them like a million times. Let's talk about it real quick. So with x, right? I'm hoping this works. Oh, there we are. Perfect. With x, right? X is traditionally a line, so that's something that we need to know, right? This is linear, okay? X squared would be something where it's like a parabola, quadratic, you could say. It's a U. Cubic would, remember, rise to the right, fall to the left, okay? So just review, by the way. X squared is kind of like an arrow that starts at 0, 0 and shoots across. Absolute value is a V. We looked at that today. And 1 over x would look something like this right here, okay? Now, just so you know, just in case you already know what's going on, you can already fast forward to the end of the video. These two are the ones that I want you to do. So these are the two that I want you to graph. Graph paper is on the back behind the homework where you turn stuff in. So if you need to get one of those, go ahead and get one of those and graph those and then turn it in on campus, okay? All right, so let's take a look at this first. Anytime, again, there's a number on the outside, C stands for any number. You could put it 2, 1, whatever, your mama, I don't care, put something out there. But that is a vertical shift. What is, again, at 0, 0 can then go up and down a value of C if a number is added or subtracted on the outside. When a number is added or subtracted on the inside, we use what's called a horizontal shift. And if the negative is on the outside, we call that over the x-axis. What is up now goes down, right? But then if it's in the inside, what was right goes left and what's left goes right. So just a heads up there, okay? All right, so let's take a look at this one. Again, traditionally we have a graph that's, if we had the square root of x, right? Okay, and I were to graph this, I would plug it in like, let's say a t-chart. That's what we've done before, right? Plug in 0, we get 0, right? Plug in 1, we get 1. Can't do 2 because that'd be kind of tough, but if we plug in 4, we get 2 because the square root of 4 is 2. So what we have is 4, 2, 1, 1, and 0, 0. So this graph's going to look something like this right here that keeps shooting across, right? But what happens is now we have transformations. This is -4, since it's on the outside, goes up and down. So what we're going to say is this is going to be a vertical shift down 4, right? Okay, so we got that there. The x plus 2 is a horizontal shift. So we're going to say horizontal, you can kind of abbreviate, horizontal shift. And remember, this is opposite. So up out here is what you see is what you get. So this is going to go down 4, right? But because of the x plus 2, this is going to be a horizontal shift to the left 2, okay? Because you think opposite, it's what you plug in for x to make that equal to 0. So that'd be -2 plus 2. So inside, it's got to be opposite. So this thing is going to go down 4 and left 2. So watch the new graph. This is going to go from square root of x. It's going to go left 2, down 4. Okay? Look at this point. Left 2, down 4. This point, left 2, down 4. So what happens is what was in red gets transformed. The transformation of this would be what is now in blue. And that's how we graph that right there in that example. Okay? See if we could do this one. Now, again, cubic, we're going to start with x to the third, right? And if you need a t-chart, you can. If you plugged in, let's say 0, you get 0. Plug in 1, you get 1. Plug in -1 to the third would be, I think, -1, right? Yeah. Plug in 2. Let's see, 2 to the third would be 8. Okay, so we're going to 2, 8. Well, that's high up there. Okay, 1, 1. 0, 0, -1, -1. So this thing, remember, is cubic, so it should be going down like this, right? And then this one's going to go up like so. Okay? So we got a cubic graph that looks very similar to that. Now, as we look at this, the outside stands for vertical, right? So this will be vertical shift. Remember, what you see is what you get on the outside. That'd be up 1, okay? And then this side, we think opposite, not x minus 3, we think opposite. So we're going to say horizontal shift. You'll see HS a lot, or VS. Horizontal shift would be right 3, because we think opposite, right? What gets plugged in for x to make it equal to 0. So each of these are going to go up 1, right 3, 2, 3, okay? Up 1, 2, 3, right 3. Up 1, boom, right? 3. This one's out there, so we're good. And this one would be right here. So this is going to go down here, and this is going to go up. Again, notice it's the same graph. It's just transformed to the right 3 and up 1. Again, this is just simplifying it a little bit so we don't have to do T-charts for every one of these. We can kind of see transformations and see, hey, how are these transformed? How are these graphs transformed there? Okay? All right, so try this one. Again, this was going to go up 1, right 2. So I like to say, okay, so this is R2HS, which means right 2 horizontal shift. This is up 1 vertical shift, BS, okay? And then the negative is reflected. That's why Coach J was being crazy, because the reflection, okay? All right, so remember absolute value of X, okay? Absolute value of X means that normally we would be in this spot, okay? If you were to graph this here, do a little T-chart. But now since we are, we go right 2, okay? So this is literally going to go right 2, up 1, okay? So this is going to go down here. So it goes right 2, up 1, because that's, again, your minimum. Now it's going to be a maximum. Right 2, up 1. Did I do that right? Right 2, up 1. Yep. And this one's going right 2, up 1. Oh, I forgot reflected. I'm sorry. So really what we said here, my fault, forgot the reflection. What we're doing is when we go, okay, so we're going to go reflect. You could actually reflect it first. It might be easier, actually. Let me teach it this way. Let's reflect it first. So what was up now goes down, okay? So that's this. But then we're not done, right? What we've got to do now is take this and now go right 2, up 1. So let's go right 2, up 1. So we'll go right 2, up 1. And what we're going to have is really what's in black. I know it looks confusing, but we reflect it first, and then once we do that, then we can go right 2, up 1. So the one in black is that the real one. This is the original. The orange is what's reflected, and this is the ending one, what's in black right there, okay? Now, the only other thing I will tell you is that sometimes this thing can be skinny or really wide, right? So we could be really skinny. This is just an example. Or really wide. So when I think of a rubber band, the higher the number, okay, the higher the number, the more thin it will get. Think of it like the tension will be greater, therefore it will be skinnier. So if like I had 2x squared, this is going to be skinnier, but if it was like between 0 and 1, say a fraction, this is when that's going to be a lot wider, okay? And you could kind of plug things in to kind of figure out what will happen. So if I have 1/4 here, we call that a shrink. When it pushes down, so it's kind of going to be, it's going to be wider on this side. You see this 5? 5 means that the higher the number, that means the skinnier it will get. Does that make sense? So like it's stretched out. So we'll say that this is a stretch. Okay. All right. Say again, -3 again will be reflected, right, and go right 2. But the 3 tells me that we are going to stretch it out because that number is greater. It's still reflected, but it will be stretched out, okay? And if this number is 1/3, that x squared, it's going to end up being out there. It's between 0 and 1, so we call it a shrink, okay? So if you were to do one, here's one here. We'll do this one and be good, okay? What would normally be here, right? So let me graph the normal absolute value function here. There you go. Again, this, if I used a T-chart, I would find this out. This negative would be reflected. Okay, so we'll put reflected. This is going to go right 2, horizontal shift, okay, because right 2. And then the 3 would be a stretch, okay? So to see like what all this entails, what I'm going to do is I'm going to, I know it's going to go reflect, right? So it's going to go down, down here. And once I know it goes down here, then it's going to go down to the right. So it should look something like this, okay? Should look something like this. Now, so because again, we went reflected downward, but then we went right 2, okay? But now we've got to bring the 3 in play. And we do that by just plugging in a couple values, probably 1 or 2 to the left and right of what we call my vertex here. So let's plug in 1 and 3. And let's see how skinny it is. So 1 minus 2 is -1. Absolute value of -1 is 1. 1 times -3 is -3. So 1 -3 is what we have here. Okay, again, stretchy, it's going to be skinnier. Plug in 3. 3 minus 2 is 1. Absolute value of 1 is 1. 1 times -3 is -3. So 3, -3. So our graph should look something like what's in blue. Okay. Again, the red is correct if this 3 was not there, but because it is, then it would be skinnier on that side. Again, just a heads up, make sure that you graph these two. Tell me the types of transformations that are occurring. If you could, if you've already done it, that's fine. But if you could put a negative right here, just so we have one that's reflected. And again, I'm hoping that that will be of help to you as we progress forward. Thank you all so much. Man, hopefully that was worth at least a little bit there. Hopefully it helped you out. We'll talk to y'all later. We'll discuss a little more on Monday, and we'll go from there. See y'all. Bye.